Each and every one of you watching this video has definitely had this experience where hours can just fly by when you're doing something interesting, fun, or even if you're just asleep. But if you have to wait somewhere for even just 5 minutes, say that's just nervously fidgeting in a chair before a job interview, gazing at the wall in the waiting room of a dental practice, it can feel like the longest 5 minutes of your life. But that's really bizarre, isn't it? It doesn't make sense that 5 minutes can feel longer than an hour, but to many of us, that is actually an experience that we have had. And now a proposed explanation for this is that our brains get so distracted by the events going on around us, like, if we're engaged or enjoying something, that we just forget to pay attention to the passing of time. And there's probably a lot of validity to that argument. But what if there were to be another explanation for this phenomenon? Perhaps we could posit that time doesn't actually progress at the same rate for people everywhere in the world. I mean, we've all experienced different rates of time passing, but we are also aware that time is passing for everybody else at the same time that it's passing for us. And that throws up a massive problem, because how could time seemingly be passing more slowly for me in the same instance that time is passing really quickly for another person? The result of that would mean that I was left in the past and the other person has progressed into my future, and that completely destroys the idea of linear time that most of us share. Before we move any further, let me define what linear time actually is. This basically means that time flows irreversibly from past to present to future, and at the same rate for everybody everywhere. It is easiest to imagine this as a point on a line. The point starts at one end of the line and continues to move along the line in one direction, ahead of itself, at the same speed. And that dot represents the passage of time for everybody everywhere. So that begs the obvious question, what if linear time wasn't actually the full story, or perhaps isn't actually the correct way to view time? Now, it's probably a good time to throw in there that I am by no means an expert on this matter, and I'm trying to make sense of this topic just as much as you guys are. So I'll probably get a lot of this wrong. In fact, I definitely will. And feel free to point out where I do misstep in the comments. I'd love to hear what I got wrong. And this is the moment where I introduce the concept of non-linear time to you. This basically means that time doesn't have to be passing at the same rate for everybody everywhere. And that makes it much easier to explain why we all perceive the passage of time very differently. I have very proudly come up with my own way to visualize non-linear time. Imagine that you're in a mountain range, complete with the tall peaks of the mountains and the low points at the bottom of all, the river valleys. If you were standing in a valley, you would have no idea how many mountains there were in the mountain range. And likewise, if you were standing on a mountain peak, you would have no idea how many valleys there were in the mountain range. You wouldn't be able to see them. However, if you were flying above the mountain range, you would be able to see each peak and each valley that makes up the entire mountain range. Imagine that the valleys are the areas where people perceive the passage of time to be slower, and that the mountain peaks are areas where people perceive the passage of time to be faster. Each person's experience of time in the mountain range will differ, whether if it is by a tiny amount, which would be analogous to standing a meter further up a mountain compared to somebody else, or by a large amount, akin to standing on a mountaintop compared to a person standing in the lowest point of a valley. The important part of it all is that regardless of the different experiences of all of the people within the mountain range, each valley and peak is itself a part of the complete mountain range. Thus, we could compare that mountain range to the encapsulation of all experiences of time in our universe, complete with any laws that govern the phenomenon of time. Time still exists as an intricate pattern throughout the universe, but people's individual perception of time differs. This concept shares a lot to Albert Einstein's proposed theory of relativity. With relation to time, it basically states that the closer an object's speed is to the speed of light, the slower the passage of time will be for that object. That is a process called time dilation. Now, obviously, this doesn't explain why humans would perceive the passage of time differently between each other, because I certainly can't move fast enough to get close to the speed of light. And I would be very surprised if you could as well. There's also another layer to this theory called gravitational time dilation. This posits that time passes more slowly the stronger the gravitational field that an object is in. So the way to slow the passage of time the most for yourself, if you didn't want to become old, You have to just move really, really fast, as close to the speed of light as possible, and also be as close to the largest possible object as you could be. If we take the theory in a more general sense, another important assertion is that because the speed of light is a constant, space and time are not and cannot be separate, absolute entities. This means that they interact to form a four-dimensional thing called space-time. Under the theory, gravity interacts with space-time by bending it, and this means that light or any other objects passing through that region of space-time will take the shortest possible path through the bent space-time. And it means that the objects that are moving through space-time are technically moving in a straight line. It's just that the actual space that they exist within has become curved. And the important point from all of that is that there's a theory out there which posits that time passes differently based on a certain set of conditions around an object. Now, as many of you probably already know, there's a very large problem with the theory of relativity. Basically, relativity is a theory that works for a lot of massive objects, like stars, planets, asteroids. But if you were to zoom in onto the smallest possible particles that exist in the universe, the theory of relativity doesn't actually work for them. Instead, these tiny particles operate off a probabilistic model. Basically, we can never with 100% certainty know whether or not a particle will be in a certain place at a certain time, but we can guess based on probabilities. So how does this actually affect time? Well, I was shocked to find out that at the level of the smallest particles in the universe, the laws of physics appear to be time reversible. This means that it is only at the macroscopic level, that is the level of larger objects, that time actually does appear to flow in one direction. And that would be an example of nonlinear time at the microscopic level. There's also the idea of superposition, and this posits that particles exist in a superposition of all possible states and times until they're observed by something, in which case the particle has to settle into a definite reality. So where do we actually get with all of this? Well, relativity argues that time passes differently for objects based on their speeds and their positions within gravitational fields. Quantum theory argues that time isn't actually universal in flowing in one direction, because at the smallest levels of size, the laws of physics are actually time reversible. It also argues that particles, until they're observed by something, exist in a superposition across multiple points in time, meaning that something might be able to exist across multiple times and not just within a single point of time. Now that completely destroys the notion of linear time that we have. Whether or not these things are perfectly true or the correct explanations, we have no idea. And these all, open up the possibilities that challenge the notion of linear time throughout the universe. And these are definitely starts to understanding why humans might perceive time differently based on the positions that they find themselves in. I can by no means explain where this is going to go in perfectly explaining the quirkiness of time, but I thought it was interesting to share some of these theories and provoke some questions around our shared notions of linear time.